Hello and welcome to the next installment in this series where we'll be covering the yield keyword and generators. In order to understand those, we need to make sure that we know iteration inside out. You'll have no doubt come across for statements. Let's take a look at one here. The output is the same as print 1, print 2, print 3, print 4 and print 5. I'm going to show you that you can understand iteration by considering the context, the iterable object, and the iterator object. First, let's loop over a dictionary. Do we get the keys or the values? We get the keys. It's trivial to find the value ourselves, even though the dict object has methods for this. We can iterate over strings too. Each individual character in the string is the next to be assigned to X in the loop. Let's take a look at this more closely. We'll be working with the same list that we had earlier. Running dir on it, we get to see all of the dunder methods and non-dunder methods available to us. Dunder iter is available on iterable objects. What it does is it returns the iterator object. Assigning this iterator object to I, we can try and print it, but we just get the repr returned back to us. Of the objects available, the one of interest is dunder next. Calling next gives us 1. When we run it again, we get 2. An easier syntax for this is to call the next method and to pass in our iterator to it. Our iterator hasn't changed. It's at the same memory address. As you would expect, we get 3, 4, and 5. What do we get if we run it a 6th time? An exception. A stop iteration exception. What's going on under the covers of a for loop? In the context of a for loop, the iterator object is acquired from the iterable object, and then the return value of next iterator is assigned to X. Our statements run, and these run for each of the values returned by next. When we're exhausted of values, next will return stop iteration. This is caught instead of us seeing it. A generator is a function that produces a sequence of results instead of a single value. We can create a generator function, and to do so, we just need to put a yield keyword anywhere in that function. When we call this function, we create a generator object, but we don't actually start running the function. The object produced does support the iteration protocol. That means that with this object, we can call next. But even though we've defined the whole function, we don't get all of the results. Calling next on a generator object results in the underlying function code being run to and including the yield keyword. The function's then suspended, but that generator object retains state and it knows what it's done and what it hasn't done. So when we call next again, the code is then resumed and it stops short of the next yield. Generators do differ from iterables in many ways. For our next example, we're going to take a look at a list comprehension and then a generator expression. A fast way of producing a generator object is to write a list comprehension and then change these square brackets to parentheses. We can loop over the list as many times as we want. When we loop over our generator object, all seems well at first. It seems like the generator is empty. Getting the results from a generator is a one-time operation. Once you've received a result from a generator, that's it. It's exhausted. In fact, if you want to look up item at index 4, say, of the results that a generator object contains, the generator has to get there by going through objects at index 0, 1, 2, and 3 first. So afterwards, if we call next, we're going to get the object at index 5, and there'll be no way to know what those items before it were. A function becomes a generator function if it has at least one yield in there. When trying to understand how to convert a function into a list comprehension, there is a certain mental thought process that happens. Much in the same way that the return keyword is omitted, so for generator objects, the yield is omitted. This next function concatenates items from one or more sources into a single sequence of items. So for instance, if we pass in a list that itself is made up of two lists, what's returned is each item from each item in the original list. So if we think of the first part as taking each item from the list, so each item from the list would be list 1 and list 2, and then we take each individual item from the first list and each individual item from the second list. And in that way, when we call next on the object produced from this generator function, we get 1 all the way to 6. Yield from is a way of shortening this syntax, and this is exactly what yield from does. Yield from can also be used to delegate, so we can yield from and then give a function. But the function has to be one which itself is a generator function. Yield from that function which itself yields. It's even possible to send values into yield, and then we can use the yield as, in effect, a print statement or assign whatever comes in to a variable. When it's used in this way, it's known as a coroutine. And if there's interest, I can show you some more involved examples using these coroutines. That's all we have time for in this installment. Please don't forget to like and subscribe if you've enjoyed this. Do pass on the message so that others can enjoy this content too.